Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform. One more thing. Let me tell you about a new sponsor, Raygun. If you're wanting to detect and diagnose errors and crashes in your software, even find problems that you didn't know existed to improve your software, then Raygun might be perfect for you. You add a few lines of code to your application, and in minutes you'll get real-time error reports with all the information that you need to fix bugs fast. You can even hook it up to your team chat, bug tracking, development workflow tools. Raygun covers all major web and mobile programming languages, including .NET, the full Xamarin Stack, JavaScript, and many more. Go check out Raygun today at raygun.io. I use this myself on my little startup, and I really, really recommend this product. It is a great, great product. Check it out, Raygun at raygun.io.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 481. In this episode, Scott talks with Kelsey Breseman about making the Internet of Things with JavaScript.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Kelsey Breseman. She's one of the creators of Tessel. And Tessel is a really exciting platform for making stuff, and you know that I'm excited about making, so I'm really excited to chat with you today.
I'm excited to be on here.
Thanks. Now, I was looking you up and doing all my research, and you have a degree in neural engineering, which is about the coolest sounding degree ever. Did you make that, or how does that work? What is that? What is neural engineering?
Yeah, so I made up that major, but it's based on my interest in how the human brain basically learns and grows, and I wanted to kind of approach this field that has quite a lot that we don't know in it, with a pretty hard science sort of how do we get something out of this kind of approach, and that's engineering. So I'm interested in how we can use that sort of stuff for prosthetics and for superpowers. Based on building devices that can work with the way that we think and interact with our world, even electrically, without making us have to interact with more devices than we wanted to.
Yeah, it's interesting. It sometimes feels like, you think something, but it still has to go through your fingers into a keyboard. And, you get to the point where you can type as fast as you can possibly type, but you're still going outside your body and then in order to get back inside and change something. It's an interesting topic for me because I'm a diabetic, and I'm a type 1 diabetic, and I have a number of devices attached to me. I'd love to be able to control those in some way. So I'm always thinking about the Internet of Things as it relates to those devices. But there's always an interface, there's always a button or something, isn't there?
Yeah, I mean, so you're already a bit of a cyborg, and that's really cool because it's just another way that we can use engineering to make the world react to us in a way that's responsive rather than us having to go out and do something.
And do you think of this as something where I'm going to take a device and put a helmet on my head, or how am I going to interact with devices in a world that is smart about, the way the mind works in a neural sense?
Well, actually, so I'm interested in this concept of ubiquitous computing that's born out of Xerox PARC in the 90s and Mark Weiser. And basically, the idea is that you don't have to notice that there's a device. The world just responds to you if it's acting appropriately. And one low-tech example of that is just a conference room that has a window in it, so you can walk by and know if there's something in there that shouldn't be disturbed. But a higher tech sort of implementation of that, I actually gave a talk about a year ago today at SolidCon, about how to make this stuff happen. And one of the things was I had hooked up hue lights to a Twitter API so that during my talk I could get live feedback on sentiment, and they would turn red or green based on how the audience was tweeting about me.
That is
so
really
that sort of
cool.
thing where I don't have to go out of my way to interact with it, but suddenly I have more information about the environment that I'm in.
Those kinds of experiences work amazingly until they don't work at all. Like there's like an uncanny valley of ubiquitous computing where, you walk into a room, the light goes on. You leave the room, the light goes off. But if you walk in the room and you're waving your arms around, or we've all been in a conference room late at night and the light goes out and you're like, seriously?
Yeah, absolutely. And that's very much something that a lot of us are exploring right now. If you look at the Nest thermostat, I used to use it as my canonical, this is a perfect example of ubiquitous computing. It's a thing that learns. It's a device that sits on your wall and you don't interact with it. Based on having talked to people about it, though, I've learned, and I don't have one myself, I've learned that you do have one. So maybe you can give your take on this too. But from what I've heard, it's too cool a piece of technology and people just pull out their phone all the time and interact with their thermostat. Whereas previously, even though it was much harder, people just kind of ignored it before.
Yeah.
It is, but in theory, it's ubiquitous.
Yes, absolutely. It is the iPhone of thermostats. It is a beautiful device. It turns on and glows when you walk by, and it doesn't just turn on. It kind of pulses like, oh, there you are. Hello, I'm Nest. It's something that you desperately want to interact with just because it's so pretty and it's so well designed. It is, I would have to say, from an IoT perspective, the canonical perfect example of an amazing and fun device to use. I have had exactly zero problems with it.
But although it doesn't fit my quite the model that I'm thinking of for ubiquitous computing, because you do actually want to interact with it, and ideally, it would you wouldn't even remember you had one.
Ah, interesting.
And it'd just be one less thing that you ever think about.
Does that mean that a really good, a good device or a good IoT thing, a good example of ubiquitous computing would be something that is embedded somewhere in the fridge, in the wall, in the floor, and I don't even think about it? Maybe I change the batteries every 10 years, but it just makes my life better.
Yeah, it just changes your life in a way that you just completely forget about. Think about modern conveniences such as having the availability of internet or electricity or running water. It's the kind of thing that you just kind of assume it's there, it works, you don't think about it ever, unless you go camping and then suddenly you realize, oh, I need a flashlight at night. Oh, I need to go find some water. That sort of stuff. And ideally if ubiquitous computing comes to pass the way that I someday hope it will, we'll end up with exactly that sort of interactions with all of the objects around us. Things will just react, or things will just be available when we need them. Things will just react to the way that we feel. So the lights turning off is the perfect example of something that's not quite there yet. The motion activated lights. But in theory, you should be able to walk into a room, have the lights when you need them, have them know when you don't want them on, even if you're in the room, have them save energy when you're not there. There's obvious potential there, and that's, of course, why we have them. But, yeah, we're not quite there yet.
Interesting. So, if I may, then, ubiquitous computing would be the opposite of what everyone's excited about right now, which is virtual reality and augmented reality, where people want to put us into a computer. This is more about prosthetics for able-bodied people. Also just in the sense of things that you don't put on yourself. But yeah, I'm personally not a huge fan of virtual reality and augmented reality. I do think there's some cool possibility there, but it's not something that I get excited about. I'm much more excited about how can we live in our lives augmented by technology that just gets completely out of the way. Okay. So I probably shouldn't use the word prosthesis, because you're talking about there's a computer in your mirror in the bathroom, and maybe it knows that you need to take your pill, and it just knows somehow. And you don't wear anything, right? You don't have anything on your body.
Right. Yeah, because at the moment you have to start putting stuff on yourself, that's a whole nother problem. Which is actually, it's interesting because there's different devices that exist that you do, in fact, put on and carry around. And a smartwatch, for example, would be the hot topic right now, or the fact that you now carry a cell phone and before you never would have. If it affords enough convenience, people are willing to augment themselves with an extra device. But if you look at stuff like Google Glass, something that you would have to wear and ideally not have to have a computer or a phone around, that's what was exciting about that, even though that particular one might not be the best example of a success.
Right, but there's an example of something that augmented my life or improved my life in some way, but not so much so that I would be willing to look like a huge dork.
Yeah. So there's an interesting balance between, I guess it's in the realm of retrofitting, retrofitting this kind of device to the current world, which doesn't have all these kinds of conveniences. And right now you would have to carry around the device with you to have the experience. But in theory, a future world should have, municipal devices reacting to people walking down the street, all that sort of stuff. This is a far future vision.
But we need to start building it. This is great because this gets us into what I wanted to talk to you about, which is Tessel and the Tessel 2 coming. If I wanted to build these things or even get involved in all of the great stuff that you've just been talking about, I feel like maybe 3 to 5 years ago, it would have been out of my reach as a developer. I mean, I'm a regular web developer. I know JavaScript. I know C#, and I would look upon hardware people as being just super advanced beyond, like that's just another religion that I can't be a part of. Talk to me about why, what the Tessel is.
Yeah, so in fact, that's exactly the sort of reputation of electrical engineering that we created Tessel to try and circumvent. So Tessel, if you haven't heard of it, it's a microcontroller that runs JavaScript and Node directly on it. The new one should have some Rust and Python capabilities as well. And it's got Wi-Fi built into it. And those are just features. The real idea is, say you are a web developer or somebody who doesn't even know programming. JavaScript is a relatively accessible language. And you don't really want to think about all the levels of implementation at the outset. You have an idea of a thing that you want to make. Tessel is designed so that you can get from that idea to having a working version of that thing as quickly as you can, or as quickly as possible. So what we've done is we've tried to make it as modular and abstracted as makes sense, I think, in the sense of the electrical engineering components. So we know that most web developers are kind of thrown off by the idea of building hardware. Electrical engineering is scary because things can burn up and you don't know what's happening, and there's invisible things moving around in the wires that are obviously very important, and unless you actually have some grounding in it and maybe a year or 4 of study, you're probably going to be a bit nervous. So we looked at the existing solutions. Arduino and Raspberry Pi are the 2 obvious contenders, but there's other options out there in the space. And they're quite cool, and it's much easier than 15 years ago electrical engineering. But you still have to have this step where you buy components and you plug in wires, and you have to know a little bit about, well, does it need this amount of voltage, this amount of amperage? When the signal comes back, what kind of numbers am I looking for? Is this just a voltage change? Is it trying to talk over some protocol? It gets much more complicated than it really has to in the modern time. So we have this concept of modules, which are, if you're a Node programmer, they're literally NPM modules as well as being physical components.
So there's a one-to-one mapping
of an NPM module to the physical module?
Yeah.
Yes, that's correct. And in fact, So we've got first-party ones and community-created ones, and I'll go into the community ones a bit later, but the first-party ones that we've made ourselves, it's a little red board to match your little red Tessel. It's got a standardized 10-pin layout of all the different protocols, which from an electrical engineering perspective is interesting, but let's assume that you don't care about that. It means that it plugs in, and it's pretty obvious how it plugs in. And printed right onto that circuit board is the name of the NPM module. So say you want a camera, it says camera-VC0706, right on it. And if you NPM install camera-0706 and NPM require that module, you've got a first-party library that says, yeah, you can just do camera.takePicture, and in your callback, it'll return a buffer of your image. And it's that simple at that point.
It makes you wonder why it wasn't always that simple. Like when I started playing with Arduino, I would put shields together and I would think that, okay, a shield, there'd be a library for each shield. And there is, but then you start having to think about pins. And when you stack shields, you have to think about, are those pins touching each other? The concepts of voltage and amperage still leak out.
Yeah, exactly. And it's not a bad thing to have to learn a bit about voltage. Well, okay, it's not a bad thing to learn about voltage and amperage and how electronics work. But I do think it is a bad thing to be forced to learn it when you're trying to do something else entirely.
Mm-hmm. On the website, and the website is Tessel, Tessel.io. It's probably one of the best homepages I've seen for a project in a long, long time. It's just so well designed. It does some scroll jacking that is really, really cool. But I would encourage people who are listening to scroll down at the bottom, because the part that I like the best, and here's a compliment to you, is you've got these two columns, and one's called the nitty and one's called the gritty. And it is just perfect. I think everyone should do this. So the nitty says programmable in JavaScript, support for Rust coming, deploy over Wi-Fi, support, all the nitty, all the stuff that you want. And for people who don't have English as a first language, they might find the nitty gritty to be a little confusing. But the gritty has all of the specs that you want in like 8 quick sentences. This is a really surprisingly powerful little device. You've got a 580 megahertz processor on this thing?
Yeah, we really wanted to upgrade from Tessel 1 when we made Tessel 2. Mm-hmm. And one of the major issues with the original Tessel was that though it's cool that it has Wi-Fi built into it, at the time that we built it, the technology for putting Wi-Fi on boards was not as great as we'd hoped it was. There was a chip, the CC3000, that a lot of people got really excited about, and a number of companies started doing really interesting things with it. And then that particular chip didn't deliver in the way that most of us had hoped. And so we ended up with Wi-Fi that worked most of the time. So actually one of the things that we've done with Tessel 2 is we said, well, first of all, the original Tessel was $75, and that's pretty reasonable for what it costs to build it, but pretty unreasonable if you want to buy 50 of those and teach a class.
Yep.
Or for whatever purpose, to be honest. Or actually nearer and dearer to my heart, if you wanted to embed it in something, that's a lot. So we said, well, what's a way that we can make this both cheaper and better? And so we started trying to investigate, well, where are Wi-Fi chips used a ton? Because economies of scale is the only thing that really drives down price. So we actually ended up with this MediaTek chip that you can find in routers. So the hardware on Tessel 2 is literally a router chip, and you can actually use it as a router. And it's got the processor embedded, and it's a full processor. So it actually, in this case, runs Linux, though, I hate to say that actually up front, because it should feel exactly like Tessel 1. You shouldn't feel like you're running a Linux box. It's completely abstracted away.
I see. So you could, I suppose you could theoretically break in there and mess with it if you wanted to, but knowing that it is an appliance, right? I don't want to think about that it runs Linux. I know that it runs Node and IO.
Yes, absolutely. So we're actually using the same APIs and the same command line tools with some improvements on them, because why not when you're given the chance, as the Tessel one, even though the implementation is totally different. And the main command line tools are the original, you would say. We kind of stole this from Heroku's idea because it's brilliant. It just is Tessel push my code, and then that code lives on your device.
So yeah, just like git push and Heroku push. You just that's a really nice metaphor.
Yeah, and it's very intuitive to web developers and non-web developers alike, because it's just doing exactly what you say to do. Mm-hmm. And so that will still be happening on Tessel too. And this is already implemented. We're putting together the CLI right now, and you're welcome to check out the repos. So you can Tessel run code, and it's Tessel push index.js, and it starts, in the hello world example, blinking your lights.
Before you run away from the Wi-Fi thing, I did have one last question about the Wi-Fi, because there's an unusual blade-looking design on two of the edges of the Tessel. Is that related to the Wi-Fi? Is that an antenna of some kind?
Yes, those are both antennas. And you'd have to ask our head electrical engineer, Eric, about more details on that. But that's to make sure that the Wi-Fi is very stable.
Okay, so that's good. It's interesting because there's so many devices out there where you get the device, you're like, okay, I'm ready to do something with this device, and then, I need a Wi-Fi thing. You always have to add Wi-Fi to stuff. It's so nice that it's finally coming out of the box on more devices.
Well, right. And actually, that's one of the things that we thought was really frustrating about electrical engineering that we wanted to fix is when you're doing an electrical engineering project, you get your microcontroller and then you say, okay, now what? And a lot of people leave their Pis and their Arduinos sitting in drawers because they thought it was cool, and then they didn't come up with an idea. And even if they did come up with an idea, they need a couple of wires or a couple of resistors of a specific value. And we wanted to make sure that you could just get it and go. So if you get the servo module, for example, it's not just the servo module physical thing. It also includes a servo to plug into it, and it also includes a 5-volt power adapter so that you can run your servo. And so it all comes in the box together, and the idea is you don't have to wait around. You get your thing and you make it.
That's really slick. Yeah, I'm looking at the servo module here, and that's one of the hardest things I've found in getting involved in this stuff is hooking up, servos. It's easy to get a button and an LED to work, but then it's like, all right, I want to move a motor around. Figuring out the power that runs the board and being separate from the power that runs the motors. And in this case here, you've separated that.
Right. It's separate so that you don't have to worry about drawing too much power off the board itself. You don't have to worry about how you're powering the board, because usually you're going to be powering it over USB, which is 5 volts, but we can't depend on that. Tessel 1 actually could take anything between 3.3 and 12 volts and still work. Mm-hmm. But so we wanted to make sure the servos had a consistent power supply. And then the API for it is dead simple, and I was part of designing this. You want a servo to move, it's servo.move.
As well it should be. You know what I mean? I mean, even complicated things are easy when you do it like that.
Yeah, and that's exactly the point. And that's honestly my favorite thing about Tessel is that it's very simple. When you look at the code, even if you're not much of a programmer, and I've done this with teaching people to code. I've used Tessel to teach, like, this is what JavaScript is workshops, and I have people read through it and say, so what do you think this line does, and what do you think this line does? And they read through the 10 or 20 lines of the example, and they can usually tell me, okay, this is the part where Tessel is saying that the module is connected on port A. And this is the part where it's saying, okay, well, wait until the servo module says that it's ready. Okay, now move it to this position. And it's meant to read like plain English. And it's meant to work, well, for Node programmers, it's nice that it's in that same callback and or promise format. That kind of makes sense in terms of when things happen.
Mm-hmm. I think that also, when I'm in the context of teaching people, if you sit down with like a teenager and you show them how to write alert, whatever, and run it in a web page, and they go, okay, that's basic programming. And then you say, well, let's do some hardware now. And you make that transition from people who were born on the web and they're going from web programming on something that they know, the browser, and now suddenly they're, putting something out on an LED screen. I think that's magic. They're going to think that's completely natural. Of course. Why wouldn't you do it that way?
Right. And it's actually really cool because yeah, I don't know, I've taught people, I've gone and done like a workshop for high school girls who'd never programmed before, and I sat them down and I made sure, so our start experience starts with the installation step, but there's a little link at the top of that says, if you're new to web development, take a step back and learn the basics. And it says, this is what a command line is. And it gives you a little workshop that says, okay, you should get comfortable with this. Okay, now we can go into let's install Tessel. I sit them down with that and they go through it and they try the command line and they get the concept of, oh, I'm manipulating files on my computer. That's cool. And then they go through and they install Node, and that works out better than you'd expect. And then, yeah, they by the end of, half an hour, they've made a couple things in hardware, even though it's their first time ever using JavaScript. And I think because we intentionally made Tessel to be the exact same tools and flow as web development, it would then be really easy for one of them to say, okay, now I'm going to build a website to interact with hardware, or just a website on its own. And they already have Node installed. They already understand what the CLI is. They already understand the text editor, and they maybe have Sublime or Atom. Mm-hmm. They're good to go.
Yeah. And this is flexible. Like with some systems, you'll add some modules and then you'll run out of modules. Like, okay, that's all the modules we got. But I'm looking at one here where someone has taken an old Nokia 5110 black and white, LCD screen, like the classic Nokia screen, and got it talking to a Tessel with this DIY board. And, I'm kind of digging into this, and you can go all the way down into exactly what code he used. He ported someone else's driver for this screen and then wrote, Nokia 5110.print, and he's putting it out there. I mean, that's amazing. I could teach my kids kind of the basic concepts, and they would feel like, oh, this is what's inside a cell phone,
Yeah. Well, and it's actually, so this is kind of one of my pet favorite things is I spent a lot of time working with a fellow, Kevin, to write documentation for the DIY module because, developers know what they're doing in terms of protocols. Like that's a concept that is well understood. It's just that hardware has different protocols. And so we've written actually documentation so that that's quite easy to understand what is SPI, UART, I2C, standard protocols for hardware communication. So we actually built this DIY module, and with it released some documentation on if you're just getting started with hardware, don't worry, it's not a big deal. This is what I2C is. Here's how you use it. It looks much simpler than it sounds when I say it out loud, but check out that documentation if you find that interesting. But the whole idea is even at that level, we've tried to abstract that to JavaScript and make it quite simple. So normally you would have to do this whole rigmarole of setting a baud rate to communicate over and, setting like a certain pin high for a certain amount to wake it up, all of this nonsense. We've actually abstracted APIs for Tessel such that you can say, okay, I'm making this thing, I read on the data sheet that it needs this speed of communication, and you set it up and go. And it's just not that complicated. And actually, well, so you were looking at the community modules, which is actually on tessel.io/modules, which is actually, I love that we're able to do this, to have a community that is excited about contributing these NPM libraries for hardware. So the community modules is a section for people to contribute Arduino and Raspberry Pi have created this really wonderful ecosystem and marketplace for hardware modules. They're just not the same form factor as our hardware modules. So you end up with like an Arduino heart rate sensor or an Arduino Nokia screen, as you mentioned. And it's very simple to go out and buy those, and there's Arduino libraries for them already. And so we've made it fairly simple to take that Arduino library and port it over to JavaScript and release it as a node module. And then the community libraries are for anyone who's done that or built a node module from scratch and released it with an API that's documented and just images of how to wire it up so that anybody could repeat it. And then even though it does involve a few wires, it is just about as simple as plugging in one of the first-party modules to the side, because all you have to do is plug it in where it shows plugging it in and npm install again. And that's extensible pretty much indefinitely.
Yeah, this looks like, I'm just looking around here. I'm trying to think about how I can take some of the sensors that I already have and I can plug them into the DIY board. Everything is 3.3 volts. It looks pretty straightforward.
Yeah, and that's the hope. And if we get excited about this too. So if somebody posts on the forums and says, "Hey, I'm trying to figure out how to do this, but I'm new to hardware," and they have a question, like, we're always really happy to jump in and say, "Oh, this is the thing you should look out for," or "Have you tried it this way?"
One of the last things, and I don't mean to put you on the spot, but as we end the show here, is it true that you made a CNC machine into a cake decorator?
Yes, that was a college project. My school, Olin College of Engineering, has this class called Principles of Engineering, which is basically an entire semester devoted to design build. So you pick something outlandish and then you form a team of about, I think ours was 6, and then you spend the whole semester making it from scratch. So we were all learning Python at the time. So we built a Python where you could draw like in Paint, and then one of our team members was really into machining, so he got some raw aluminum blocks and built out the mechanical assembly. And yeah, we made a cake decorator that could, if you wrote something in cursive in our Python GUI and then hit print to cake, it would look exactly like your handwriting on the top of the cake. And
where is the Auto Frost currently? Can we visit it? Is it in someone's garage?
Probably in someone's garage.
What a shame. What a shame. That's a really amazing thing. I will put links in the show notes, not only to Tessel, but also to your Instructables.com profile, so people can see the YouTube video and be excited about making as much as you are.
Oh, yeah, absolutely.
Thanks so much for chatting with me today.
Thanks for taking the time.
This has been another episode of Hansel Minutes, and we'll see you again next week.